Right, class, in this video we're going to be talking about how to find the solutions of polynomial functions, in particular using the rational root theorem. All right, so you don't have to write anything on this page if you're taking notes, but this says what types of solutions can a polynomial have, and of course they can be rational here, irrational, or non-real. All right, now it asks us how we can find those. We've done methods before like factoring, the quadratic formula, completing the square, and even graphing in previous units. However, today it says if those don't work, right, we have to use something called the rational root theorem. And that's what we're going to talk about today. The rational root theorem, I'm not a huge fan of how they write this polynomial up here. In fact, I might just give you a different one so you can kind of see what it's talking about, as I don't really like that, like I said. But let's say all of the terms have integer coefficients, meaning like maybe it's like 4x to the third minus 2x squared plus 7x minus 11, all right, something like that, where the 4, negative 2, 7, and negative 11, those are all integers, so there's no decimals or anything like that in there. It's all going to be just integers. All right, then it says every rational zero has the form p over q, where p is going to be the factor of our constant. So in that example that I gave, would be the factors of 11, and then q would be the factors of our leading coefficient, which would be 4. And if I take p over q, that's going to be all the possibilities of my rational roots. So at our first problem, it's going to ask us to write those possibilities. And if you look at what it has, it says that our p value is going to be the factors of my constant term, in this case 6. And I know factors of 6 are going to be 1, 2, 3, and 6. However, I also need plus or minus. I need both the positive and negative versions of those. So I'll say plus or minus that group. So it's kind of like 8 different factors there. All the positive ones and all the negative ones, 4 and 4. And then the q, these are going to be the factors of my leading coefficient. And the leading coefficient is 1 in this case. So just like before, I need a plus or minus 1, and that's all. And I think you would agree that if I take my list for the p's divided by the q's, well, if it's divided by 1, then that's just going to give me my same list as before. It's going to be 1 over 1, which is 1, 2 over 1 is still 2, 3 over 1 is still 3, and 6 over 1 is still 6. So my list is going to be 1, 2, 3, 6 for the possibilities of my rational roots here. All right, the next one's a little bit more interesting because the p is going to be the factors of my constant, or my constant term here. And 16 has factors of 1, 2, 4, 8, and 16. I think that's all of those. And again, I'm going to put a plus or minus in front. The q's have factors of 4, which is going to be 1, 2, and 4. So when I go to write out the p over q, the same list over 1 is going to be the same. So I'm still going to have 1, 2, 4, 8, and 16. However, if I start doing other ones like 1 over 2, well, that's going to be 1/2. And so if I were to list out this one, it's going to be 1/2. 2 over 2 is 1. That's already on my list, so I don't need to write that one again. Same with 4 over 2, which is 2, 8 over 2, which is 4, and 16 over 2, which is 8. Those are already on my list down there, so I don't need to rewrite those. Right? And then the same thing over 4. 1 over 4 is 1/4. That's going to be a new one. 2 over 4 is 1/2. That's already on my list. And same for the rest. 4 over 4 is 1. 8 over 4 is 2. 16 over 4 is 4. So I think my list for the possibilities of p over q is going to be plus or minus 1, 2, 4, 8, 16, 1/2, and 1/4. All right, now the hard part is actually using this to find the rational roots. The possibilities are the easy part. So if I try a problem here, the letter A, it asks me to find the zeros of the polynomial. And if I think that my possibilities, p over q, the p is going to be all the factors of 12. So I'm going to have, I'll say p over q, and that's going to be 1, 2, 3, 4, 6, and 12. That's a weird looking 4. There we go. All right, plus or minus all of those, divided by, and then my q is just going to be, again, 1. And we learned in that last slide that when it's over 1, that list does not change. So my possible rational roots are going to be 1, 2, 3, 4, 6, and 12. Now, when it comes to finding these, this is where it can be a little bit frustrating sometimes if the directions are just to, solve and find the zeros, because you have to go through and guess and check every single one of these. All right, let's try it. Let's start with 1, and then we'll go to 2, and so on. If I start with 1 out here, using some synthetic division, my coefficients, I'm going to have a 1, -4, 1, 12, and -12. So if I write those out, 1, -4, 1, 12, and -12. Forgot how to use synthetic division. You can reference my other videos. This is going to be 1, -3. If I add those together, times the 1 out front is still -3. 1 minus 3 is -2. 2 times -1 is -2. 12 minus 2 is 10, and 10 times 1 is still 10, and so I think I get a -2. Because this is not 0, this is not a factor. In order to be a factor of something, it has to divide evenly, so there's no remainder left over. And so I'm going to have to start over and try a different one. All right, let's start with 2 now. All right, that's my next number in my list. And if I were to get up through all those and they still don't work, I could go back and do all the negatives. So let's try 2. If I bring down a 1, 1 times 2 is 2. -4 plus 2 is -2. -2 times 2, -4. It's going to be -3. This is a -6. That's going to be +6. 6 times 2 is 12. And this time I get a 0, which is good, because that means that 2 is a 0, a rational 0 of my polynomial. All right, now what's left over, remember this is my remainder, my constant term, my x squared, and x to the third. So I have x to the third minus 2x squared minus 3x plus 6. I'm going to say equals 0, and I notice that this will work when I go to factor by grouping here. I can take out x squared out of that first group, leave me with x minus 2. Take out a -3 out of the second group to leave me with x minus 2. And let's see, this is going to leave me with x squared minus 3 for one factor, and x minus 2 for the other one. If I set this one equal to 0, x squared minus 3 equals 0, I would add 3 to both sides. And when I do that, this is actually 2 solutions because of the squared, the x squared, and because it equals 3, I can take the square root of both and just get x equals plus or minus. So my 2 solutions, plus or minus, square root of 3. That's 2 solutions. The other solution I can say is x equals 2 if I were to add that over. But remember, I need 4 because this is a degree 4 polynomial. And the 2 from the front that I was able to divide by is my 4th one. All right, now because these have doubled, or like they're the same, x equals 2 and x equals 2, that's a characteristic of a polynomial that kind of bounces off our x-axis. So if I were to go over here and click this, you can see it bounces off probably at 2 is right where that's happening. And then it crosses back here at, what was the other one? Negative square root of 3. Okay? All right, let's go to our next problem. And it says find all the zeros of each polynomial and how many solutions will there be. This one's going to be 3. So last one had 4 because it was degree 4. This is going to be degree 3, so there's 3 solutions. And my possibilities, before I get too far, we're going to have our p over q. And again, my q is 1, so whatever I get for the p list should be the same. It's going to be plus or minus the factors of 6. So 1, 2, 3, and 6. Oops, 3 and 6. Plus or minus that. And again, I'm going to start with 1 and see if it divides evenly here. So I have 1, 1, -3, and -6 for the coefficients of all my terms. Bring down the 1. 1 times 1 is 1. That's 2 times 1 is 2. -1 times 1 is -1. And this unfortunately gives me -7. So it is not a factor because it was not a 0. So let's try 2 now. I'm going to change this to be a 2. That's another possibility. And we have 1. Oops. 1 times 2 is 2. This is 3, 6, +3, and +6. Which, yes, this one does work. It gives me 0. However, I'm seeing that if this is my x squared, my x, and my constant term, unfortunately, x squared plus 3x plus 3 does not factor. I have to use the quadratic equation, which is -b plus or minus the square root of b squared oops, that's 3 squared, which is 9, minus 4ac, all divided by 2a, which is 2. And if I look at this one, 3 squared is 9, 9 minus 4 times 1 times 3. 4 times 1 is 4, 4 times 3 is 12. 9 minus 12 is going to be negative 3. So I think I end up with negative 3 plus or minus the square root of negative 3, all divided by 2. And the only thing I can do here, because this 3 is prime, is take out an I. So I have 3, or negative 3, plus or minus I root 3, all divided by 2. Now, because this is a plus or minus, this is actually 2 answers. I can say x equals all that for the 2 answers, but I need 3. If you remember, this is a degree 3 polynomial, and so the one out front that we decided divides evenly is going to be my third one. So along with these, I can also say x equals 2, and that is actually the only rational root. The other ones have i's. And you can see it never crosses my x-axis anywhere else. It only crosses probably, I would say this is exactly at 2. Okay? The third one I'm going to help us out a little bit because it is a little bit difficult. But first, let's find all of our possibilities. Since this video is getting a little bit long, my p over q's. This time q is not 1, it's a 2. So the bottom here is going to be plus or minus 1 and 2. But the top for the p's is going to be all the factors of 30, and there are a lot of them. If I think 30, what goes into 30? 1, 2, 3, 4 does not, 5 does, 6 does, 7 doesn't, 8 doesn't, 9 doesn't, 10 does, 15, and 30. So it's plus or minus that list over 1 and 2. So this list over 1 was just going to be the same. 1, 2, 3, 5, 6, 10, 15, and 30. However, if I divide by 2 now, 1 over 2 is 1/2. 2 over 2 is 1, that's already on my list. 3 halves. 5 halves. 6 over 2 is 3. 10 over 2 is 5, already on the list. 15 over 2 I don't have. Make that one a little better, that's 5 halves. 15 over 2, and I think that might be it because 30 over 2 is also 15. So my list here is huge. There's what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But I need not just the plus, but the minus of those. So there's really 24 possibilities where this could potentially cross my x-axis at a point that is rational. Right now, to help speed this along, I'm going to tell you that we're going to divide by negative 2. Right, that's definitely a possibility, right? Negative 2 on my list. And one thing I also have to be careful of is that we're missing our x squared term. They go straight from x to the third to x. So I'm going to say this is 2, negative 9, and I'm missing the x squared, 37, and negative 30. If I bring down the 2, we have 2. 2 times negative 2 is negative 4. This is negative 13 when I add. Times negative 2 is a positive 26. Plus 0 is still 26. Times 2 is 54, negative 54. This gives me negative 15. Oh, 52, I'm sorry. Got ahead of myself there. 52, now it's 15. And negative 15 times negative 2 is 30. And so because negative 30 plus 30 is 0, that is going to be a factor. Now, this also has 4 terms, just like our factor by grouping one, but you'll notice this one does not factor by grouping. The characteristic to factor by grouping is that 2 times what would have to be 13 would be the same over here. Well, 26 is bigger than the absolute value of negative 15, so I don't think factoring by grouping is going to work. Instead, I'm going to tell you that we can actually do our group again, and I want to say it's 1. Yeah, it's 1 that I can take out. Let's try it. 2 times 1 is 2. This is negative 11. Negative 11. This is positive 15 times 1. We'll cancel right there, which is good. Now I think this can factor. I have 2x squared minus 11x plus 15 equals 0. And if I factor this, that's going to be, if I use my little graphic organizer, 2 times 15 is 30. The negative 11 on the bottom, what multiplies to be 30 and adds to be negative 11? That's going to be negative 6 and negative 5. So I can split my b term with that. So I'll have 2x squared minus 6x minus 5x plus 15 equals 0. Now I can factor by grouping. I made it kind of work. Take out a 2x, leaving you with x minus 3. Over here, if I take out a negative 5, I'm also left with x minus 3. So I have 2x minus 5, x minus 3 equals 0. If I were to add 5 and divide by 2, this answer is going to be 5 halves. This one is going to be 3, which is interesting. 5 halves and 3 on the top are possibilities. 3 and 5 halves there. So since those are rational, they do cross. Those are our possibilities. Then I also need negative 2 and 1 as my other zeros. So x equals negative 2 and x equals 1. And I think since this was a degree 4 polynomial, those are going to be my 4 solutions, and they all happen to be rational here. 5 halves, 3, negative 2, and 1. So this is the rational root theorem. Hopefully this helped you out. Until next time, keep doing your math homework fast and accurately.